Hey guys, today we're going to do a quick review over Chapter 8. I might not go as in-depth in this as I'd like to if it was a normal AP test season, but it's not a normal AP test season. You have less time for your problems, so because of that, I'm going to try to show you some more shortcuts to do these. Alright, let's look at 8.1. Part A. Some of these are going to be verbose answers, so please just listen. And write down what you say. Pause, try the problem, go back. Alright, so losing weight, Gallup poll found ... 95% confidence with a margin of error of plus or minus 3% points. What's that mean? That means if you were to repeat the sampling procedure many times, on average, the sample proportion would be within 3 percentage points of the true proportion in 95% of samples. It means 95% of the time you're within 3 points. Okay? Okay? Okay. B. What about the confidence interval? So for this one, the confidence interval, they can be either plus 3 or minus 3%, right? So 59 minus 3 is 56. 59 plus 3, 62. So again, this is going to be verbose. So listen, rewind, replay. The 95% confidence intervals from 0.56 to 0.62. So that means we're 95% confidence that the interval from 0.56 to 0.62 captures the true proportion of those who would like to lose weight. All right? Now, interpret the confidence interval. So you have a confidence interval, you have a percent. I wrote that in the wrong spot. These should be down here. When you interpret this confidence interval, what you're going to say is, if we repeat the sampling procedure many times, 95% of the confidence intervals would contain the true proportion of those who would like to lose weight. So that was C. If you were to repeat the sampling procedure, 95% of the time, confidence intervals would find the true proportion of those who would want to lose weight. Phew. Sorry, I'm not writing these all out. Saves us a lot of time. Well, me a lot of time. Sorry, guys. Alright, let's look at this next beast. Alright. We're going to comment whether or not these are correct. Here's our confidence interval. So we are 95% confident that the interval from blank to blank contains mu. No, that's not correct. Because you either have it or you don't. If you have it, it's 100%. If you don't, it's 0. So this is just given one sample, not many. It's just given one sample. So B. There's 95% confidence that the interval from blank to blank contains X. No, that's just any random number. No. Because there's a 0% chance. No, that's just not. No. The interval was constructed using methods and procedures to capture a true mean in 95% of all possible samples. That is correct. That is what a confidence interval does. It says if you do it many times, 95% of them, or 95% of the samples will be within that interval. Right, D is incorrect. Because it's just no. And E, that is a correct interpretation of it. Okay? You either have it or you don't. It's either 100 or not. Don't spend too much time thinking about this. So let's talk about what happens when you change intervals or confidence. So, as confidence goes up, your interval also gets larger. Because the larger the interval, the more likely the true mean is in it. So B, sample size decrease. The smaller your sample size, the bigger your standard deviation. So if your sample decreases, your interval has to get bigger because it's less precise. All right. Sorry, that was really fast and painful. All right, guys, I'm going to try something different for this one. So read the problem and think about it. We'll check conditions verbally, and then I'm going to switch over to another video. I'm going to be using my calculator on my phone. I'm going to try something here. We'll see if it works and show you how to do confidence intervals on your calculator, and we'll try it. All right, let's check our conditions on this beast. Here's my Moby. So is it random? Is it a simple random sample? Yes, because it says so. Is it normal? So is n times p and n times 1 minus p, that's like both greater than 10 or equal to? Yes, it is, because 0.669 times 124, well, that's 83. And then the other part would be 40 about. So yeah, they're both bigger than 10, so it's normal. Is it independent? Is that less than 10% of all couples? Yeah, 124 is less than 10% of all couples. All right. So I'm going to go to the calculator now. All right. I'm actually going to put a break in this so I remember to do that. All right, guys, this is the kissing the right way confidence interval. I'm going to hit stat, go to test. We are looking for one sample z interval. 1. There we go. All right, so x is how many people did it. So x was 83 out of 124 people. Confidence interval of 0.95, and I'm going to hit calculate. And bada boom, bada bing. There's our confidence interval. We are 95% confident that the interval from 0.586 to 0.752 captures the true portion of couples who tilt their heads to the right when they kiss. All right, next problem. Tattoos. Should you get a tattoo? Probably not. Now, what if you want to estimate within 95% with a margin of error being no more than 0.1? How many students would you need for the survey? That's a good question. Well, you want your margin of error, your MO, right, to be less than or equal to 0.1. Now your margin of error is equal to 1.96. I got the 1.96 because that's our critical value at 95%. Okay, remember 1.96 and your 1.65 and your 90-95 and 99% confidence interval for your that their z. That's your z, right? Because it's z times square root of proportion times 1 minus your proportion over your number. That's your margin of error, right? Right. All right, so we're going to do our 1.96, our z, times, now we don't know the true proportion, so we're going to use 0.5 and 1 minus 0.5. We're just going to assume half. We're looking for n, the number that gives us a margin of error that's less than or equal to 0.1. All right? Now from here, what I do is divide both sides by 1.96. Cancel, they cancel, right? Then I'd square both sides to get rid of that square root. From there I get 0.5 times 0.5, which is what, 0.25? Yeah, it's 0.25. So I get 0.25 over n is less than or equal to, what is that gobbledygook? What's 1.1 divided by 1.96? Let's do some calculations. And square. So I got 0.25 0.02603. Switch my n in that number because proportions over whatever that is. So let's try that in our calculator. I got 96. Oh, guys, I had to switch this too. You should have divide and such, but you should just realize you need 96 or more people, because the more people you have, the more accurate it is. So that's our magic number. My worst video of all time. Maybe. Bomb 5. How much time on homework? Alright. So here we're doing 90%. We are looking at a mean, not a standard deviation this time. So it's going to be a little bit different. Our mo for mean is going to be our 1.645. Where did I get 1.645? Because it was a 90% confidence interval, so our z changes. Times our standard deviation is 154 over square root of n, where n is our number. Because remember, it's our standard deviation over square root of n. Okay? Standard. Alright. So let's start solving. We want it to be less than or equal to margin of error of 30 minutes. Confidence level. Margin of error of less than 30 minutes. 30. Does he want the... Yeah, I'm going to put 30 here. Okay. So, I'm going to move this n over right now. I'm going to times this by square root of n. I'm going to divide by 30. Okay? Can I do that? Times both sides by n. Divide both sides by 30. Alright, good. Let's do it. Now, let's do some math. Alright. So I multiply, divide by 30, and then square it. When I do that, I get I got 71. Alright, so you have to have at least 71 students. Actually 72, because you always have to round up. At least 72 students need to take the survey to get that margin of error. I'm not too worried about this one, actually. Alright, let's keep trucking. Alright guys, looking at 8.3 in this poorly made video. I apologize for everything I've ever put you through. Oh my gosh, I gotta move that back. Alright, SAT test scores. You can read it, try it. Standard deviation about 50. How large do you need to estimate within 2 points with a 95% confidence interval? So, we want our margin of error to be less than 2, right? Our z is going to be 1.96 because 95% confidence times our standard deviation of 50 over square root of n. Alright, I'm going to times both sides by square root of n. Pow. Right. And divide by 2. Oh, okay. I'm plugging this in my calculator. I got something. And I'm going to square both sides. I'm going to square this beast. And I got 2,401. Now, the reason why I'm always changing these to greater than is because when you square it, you have to do the less than or greater than, because squaring gets rid of negatives. And we know the bigger the sample, the more accurate it is. So we want to be bigger than 2,401. All right. Time to travel, time to work, time travel to work. All right. Look at this beast. So standard error. What's standard error? What's your standard deviation? Whoa! Divide by square root of n. So for this one, it's going to be 21.88 divided by square root of 20, which is 4.89. Now to interpret that, I would say, given repeated sampling, the average distance between sample means and population mean will be about 4.89 minutes. All right? That's the interpret. The Muppets once said, we're moving right along. Kermit the Frog here. Oh no, don't flag me, Disney. All right. Oh, ay caramba. I'm going to do this on my calculator too and try to plug it in. Wish me luck with this experiment. Anyway, pause it, read the question. I'm going to do it on the calculator. You can check, is it random? Yes, it says it's random. Is it normal? So normal, you'd have to actually do the dot plot to show normal. For normal, you're going to dot plot it. Dot plot and say no outliers. Remember, because they don't actually tell you it's normal, and you don't have enough data to show. You're doing mean, so it's less than 30. So you'd have to show no skew. And is that less than 10% of all of it? Yeah, it is. So I'm going to show you how to do this one and the other one on your calculators. Hopefully it works. Wish me luck. See ya. Alright guys, here goes nothing. I'm trying to record this on my telephone machine. Alright, so for the vitamin C content, hit stat, edit, and then you actually type in your data. You can use this to also look at the dot plot. Alright, and then from here to actually get my confidence interval, I'm going to go to stat, test. Alright, because this is mean, it's going to be, I'm looking for an interval. I'm going to do a t interval, right? It's going to be data. I'm using list 1. Yep. Frequency 1. Confidence level for this one is 95%, so we're good there. I'm going to hit enter. And it's going to think. And bada boom, bada bing. That's our confidence interval from 16.5 to 28.5. To interpret, you would say that the confidence interval from blank to blank, we are 95% confident that the interval from 16.49 to 28.51 milligrams per 100 grams captures the true mean amount of vitamin C in this production run. All right. Thanks, guys.